Welcome to the chapter on Mathematics for Electronics Engineers. Mathematics is a fundamental tool for electronics engineers. This chapter will cover essential mathematical concepts that are crucial for understanding and designing electronic systems. In this chapter, we will cover solving equations, working with complex numbers, and applying calculus in electronics engineering. Linear equations are equations of the first order. They are written in the form ax plus b equals 0, where a and b are constants. To solve for x, rearrange the equation as x equals negative b divided by a. Let's solve the equation 3x plus 6 equals 0. First, subtract 6 from both sides to get 3-6. Then divide both sides by 3 to find x equals -2. Quadratic equations are second-order polynomial equations in a single variable x with the form ax squared plus bx plus c equals 0. The solutions can be found using the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's solve the quadratic equation. X squared minus 4x plus 4 equals 0. Using the quadratic formula, we substitute the values into the formula, which gives x equals 4 plus or minus the square root of 16 minus 16 divided by 2. This simplifies to x equals 2. A complex number is written as z equals a plus bi, where a is the real part and b is the imaginary part. The imaginary unit I is defined as the square root of -1. When adding complex numbers, you add the real parts and the imaginary parts separately. For example, a plus bi added to c plus di gives a plus c plus b plus di. Subtraction follows the same rule but with minus instead of plus. For multiplication, multiply the terms using the distributive property. Division involves multiplying by the conjugate of the denominator to simplify the expression. Let's add the complex numbers 3 plus 4i and 1 plus 2i. Adding the real parts, we get 3 plus 1 equals 4. Adding the imaginary parts, we get 4 plus 2 equals 6. Therefore, the sum is 4 plus 6i. A complex number can also be represented in polar form as z equals r times cosine theta plus I sine theta, where r is the magnitude and theta is the phase angle. The magnitude r is found by taking the square root of a squared plus b squared, and the phase angle theta is found using the inverse tangent of b divided by a. Let's convert the complex number 1 plus I to polar form. First, find the magnitude r equals the square root of 1 squared plus 1 squared, which is the square root of 2. Next, find the phase angle theta equals the inverse tangent of 1 over 1, which equals pi over 4. Therefore, the polar form is r equals the square root of 2 times cosine of pi over 4 plus I sine of pi over 4. Differentiation measures how a function changes as its input changes. The derivative of a function f of x is written as f prime of x, or df divided by dx. Let's find the derivative of f of x equals x squared. Using the power rule, the derivative is 2x. Integration is the reverse process of differentiation. It is used to find areas under curves. The integral of a function f of x is written as the integral of f of x with respect to x. Let's find the integral of 2x. Using the power rule for integration, the integral is x squared plus c, where c is the constant of integration. Calculus has various applications in electronics. For example, in RC circuits, the voltage across a capacitor can be found using integration. In signal processing, differentiation and integration are used in analyzing and designing filters. In an RC circuit, the voltage across the capacitor is given by the equation V of t equals V0 times e raised to the power of -t over RC, where V0 is the initial voltage, R is the resistance, and C is the capacitance. Understanding these mathematical concepts is crucial for electronics engineers. Solving equations, working with complex numbers, and applying calculus are foundational skills that will be used throughout your studies and career in electronics engineering. Thank you for watching this chapter on Mathematics for Electronics Engineers. We hope you found it informative and helpful.